This is part 2 in a series of 4 Excel tutorials for beginners. In this tutorial, we will learn how to perform a linear regression analysis using the LINEST function. Here is the properly formatted spreadsheet that we constructed in part 1 of this tutorial. Next, we want to perform a linear regression of our data. Specifically, I'm interested in the relationship between protein concentration and absorbance. We can perform a linear regression analysis in order to discover this relationship. In Excel, there are several ways to do this, but the easiest way is to use the LINEST function. The LINEST function is a complete linear least squares curve fitting routine that produces uncertainty estimates for the fit values. The LINEST function is an example of an array function. Array functions are functions that produce results in several cells. In order to do linear regression using the LINEST function, the first thing we need to do is specify the size of the array. For LINEST, the array is 2 columns wide and 5 rows deep. Next, with the array highlighted, we click on Insert Function next to the formula bar, and under the statistical group, we can scroll down and find the LINEST function, and then click OK. We will get the box specifying the function arguments. First, we need to define our y values, so I'll click on this arrow right here, which brings me back to the spreadsheet, and I will highlight the absorbance values, and then click on this down arrow to come back to the pop-up box. I'll do the same thing for the x's. I click on this arrow, and our x values are the protein concentrations. And again, I can go back to this arrow to come back to the pop-up box. Here, I will type true and also true here, and then click OK. The last step is to go up to the formula bar and highlight the entire array function, including the equal sign, and then if you're on a Windows machine, hold down the Control and the Shift buttons and then type Enter, and the LINEST function data will appear. I will pause the program for a moment and I will type in the definitions of these numbers. In order to make my LINEST data a little easier to see, I'm going to put a box around it. And I'd like to highlight what some of these values are. This value here is the slope of the line that we will see in a graph, which we will plot in the next tutorial, where we will plot protein concentration on the x-axis and absorbance on the y-axis. This is the error in the slope. This is the y-intercept, and this is the error in the y-intercept. This is the r-squared value. That indicates how well the data conform to a straight line. If the data conformed perfectly, the r-squared value would be equal to 1, indicating a positive correlation. R-squared could also be -1 if the data were negatively correlated. Here, our value is very close to 1, indicating a strong positive correlation between protein concentration and absorbance. The value of the error can give us an idea of how many significant figures we should display here. If I go up to decrease decimal, I'm going to decrease the decimal until I have only one significant figure in my error. Here, it turns out that the number that I get, 0.01, is 2 places past the decimal point. So that means I will adjust my slope value so that it is also 2 places past the decimal point. I can do the same thing for the error on the y-intercept. I'm going to decrease the number of decimals until I obtain one significant figure. It happens to be 3 places past the decimal point, so I will adjust my y-intercept so it is also 3 places past the decimal point. What we notice is that our error is actually greater than the value itself. Essentially what this means is that the y-intercept essentially is 0. And that makes sense because a solution that has no protein in it, essentially it's completely water, should not have any appreciable absorbance at 280 nanometers. I will also use the decrease decimal function to decrease the number of decimals in the remaining data of my array function.